Okay, this is for Algebra 2, Unit 8, Lesson 9. We are solving rational equations. Okay, so we are solving right now. In the past, we have been simplifying, which involved a lot of factoring and canceling out, combining like terms even, and most of our answers still had variables still in them. We just got the expression in its most simple terms. But now that we're solving for our variable or x, we're wanting to say that our variable equals a number. So it changes our process a little bit. Now we're going to have two different types of rational equations. So we've got these two different methods up here, method 1 and method 2. Method 1 is for proportions. So a proportion, if you recall, you've probably seen lots of proportions in your life, it's going back to pre-algebra or before, but a proportion is when you have one fraction equal to one fraction. Okay, just one fraction on either side of the equal sign. And that's what we have here on number 1. One fraction equal to one fraction. The sides are proportional. We're actually saying when they're proportional that the two sides are equal, and we're trying to find the number for x that makes them equal to each other. But when you just have this situation of a proportion, you do something really easy. You cross multiply to solve, and you've probably done this a lot in your math lives. So when we cross multiply, we're getting rid of the denominator, which always makes it a lot easier to solve. So to solve on number 1, to cross multiply, I would multiply 7 times x. We multiply on the diagonal, so we get 7x, and then you always put your equal sign after you multiply the first cross, and then we multiply our second cross, which is 4 to x minus 6. But anytime you have a binomial, trinomial, you have to think of there being parentheses around that term. So we get multiplied to everything. So I'd write it like this, 4 times x minus 6. Now there's no more denominator, and it's just a super simple equation to solve. So there's my equal sign. I need to distribute on the right side. So we have 4x, 4 times negative 6 is negative 24. Then I look at my x's. Okay, they're both to the power of 1, so this is linear. So I need to get my x's on one side of the equal sign, my constants on the opposite. So I'm going to minus 4x from both sides. I get 3x equals negative 24, and I finish it off by dividing by the coefficient of x. So I'm saying x is equal to negative 8. And I just do a quick check on my x's to make sure that I am not getting an answer that would create a 0 in the denominator. We don't want any undefined situations. So if I plugged negative 8 into either x here, I'd never get a 0. So that means that, okay, negative 8 is my answer. Okay, going to number 4 next in our notes. We have m plus 3 over 3, one fraction, equal to what? Another one fraction, 8 over m minus 2. This is a proportion, so I can cross multiply to get rid of my denominator. My first cross, I'm doing m plus 3 times m minus 2. And to know how we should correctly multiply, again, think of there being parentheses around those two terms. So I've got m plus 3 times m minus 2. Then I put my equal sign. I multiply on the other cross. 3 times 8 is 24. Okay, to simplify and solve this equation now, I need to next get rid of my parentheses by FOILing. So I've got m times m, which is m squared. M times negative 2 is negative 2m. 3 times m is positive 3m. 3 times negative 2 is negative 6, and it's equal to 24 still. All right, now on this problem, because of this squared, okay, we are quadratic, which means we need to solve for m by getting it set equal to 0, factoring, and then pulling our solutions out of those factors. So I need to combine my like terms, but also get it set equal to 0 by subtracting 24. So I have m squared, negative 2 plus 3 is positive 1m, and negative 6 and negative 24 make negative 30. Okay, next we would factor. We have 3 terms, so we're going to do our factor tree, looking for 2 numbers that multiply to negative 30 and subtract to positive 1. Those 2 numbers would be positive 6 and negative 5. So we write it in factored form. M plus 6 times m minus 5, it's still equal to 0. And then we'll do our t-bar. if each factor is set equal to 0, our two solutions are -6 and +5. And again, I check wherever I have a variable in the denominator and just make a quick check that I don't get a 0 here. -6 minus 2 doesn't make 0, neither does 5 minus 2. So we have those two solutions. Okay, next moving on to number 5. Also a proportion, so we will cross multiply. We're going to multiply y times y plus 5. So y times y plus 5. Even if I don't draw the parentheses on there, they're still implied. Equals 3 times y plus 8. All right, here's my equal sign. I need to simplify each side, get rid of the parentheses. Whoops. So we're going to distribute. Y times y is y squared. Y times 5 is 5y. Equals, distribute 3. We have 3y. 3 times 8 is 24. Okay, this is also quadratic because of that squared. So we need it set equal to 0, bringing everything over to y squared side. So minus 3y joins up with its like term 5y minus 24. It goes at the end. So we have y squared, 5 minus 3 gives us positive 2y minus 24, and it's equal to 0. To finish solving for y, we next need to factor. So we're looking for two numbers that multiply to -24 and also subtract to +2. Those two numbers would be +6 and -4. So we write it in factored form, y plus 6 times y minus 4, it equals 0. We t-bar, and we get y equals -6 and y equals +4. And check in your variable in the denominator. We don't get a 0, so again, two good solutions. Okay, moving on from proportions. On number 7, we have here 4/3 minus 7 over n equals 1/6. So it's still a rational equation, but it's no longer a proportion because here on the left side, we have got two terms equal to one term. So that's not a proportion. We cannot solve this by cross multiplying. But we still need to solve for n, and it's in the denominator. So what we're going to do here, it says on the front for method 2, this is a method 2 situation that we're going to use an LCD, or least common denominator. Our goal is to get rid of the denominators still so that we are left with a simple equation to solve. So if we use the least common denominator, we'll be able, because it's common to all of them, we'll be able to cancel them all out. We'll multiply the leftover parts into the numerator and just solve that equation. So let's see what that looks like. Looking at these three denominators, we have, 3n and 6. I want the smallest number that they can all, or term even, that they can all become, and that would be 6n. So whatever that LCD is, you're going to basically multiply it to each term in the problem. And I'm going to show it like this. Not a lot of room. Okay, so it goes to all three. And then what I do now is I cancel out, the LCD that I wrote here at the top with each denominator. I want each denominator to fully go away or cancel out. So 3 goes into 6n, and I'm left with 2n. And these two parts that are left over, the 2n and the 4, they are going to multiply, and they make 8n. I have a minus sign that comes next. And then in the middle fraction, the denominator n cancels off the n from the LCD, and I'm left with 6 and 7, which multiply to make 42. See, getting rid of all these denominators. Then my equal sign, and then my last fraction, the denominator 6 cancels with the 6 from the 6n, and I'm left with the 1n that multiply to just make n. So it's kind of like magic, but not, it's just math. Use the LCD to cancel out all denominators. Now I look at my equation that's left, and I have just a linear equation to solve. So the most simple way to solve that would be to subtract 8n from each side. I have negative 42 equals negative 7n's. Divide both sides by negative 7. and we get n equals positive 6. Negative divided by a negative. I look at my only n in the problem. It does not create a 0, so this is a good answer. Okay, next on number 8. Okay, we're still using method 2, using an LCD to cancel out our denominators since we are not proportional. Okay, so looking for a least common denominator. I have in the denominator, we've got k, 2, and k. So the smallest term they can all become is 2k. So my next step now is to multiply that 2k, that LCD, to each term in this rational equation. And then I'm looking at my denominator and each LCD in the fraction, and I'm canceling out the common part. So in the first fraction, I get k that cancels out from each. I'm left with the 2 and the 3 that will multiply to make 6. Got a minus sign. In the middle fraction, I can cancel out the 2's, and I'm left with 1 times k, which is just k. Then my equal sign. My last fraction, the k's cancel out, and I'm left with a 2 times 12 to make 24. And this is also just a nice little linear equation to finish solving. I'm going to subtract 6 from both sides. Bring down that negative k. It equals 18. And to finish solving for k, we'll divide both sides by -1. So k is equal to -18. Does not create a 0 in the denominator, so it's good. Okay, on number 9, we're leveling up a little bit. Our denominators are no longer monomials, but we still need to find an LCD between them. I've got a denominator p minus 2. If you have a whole number, its denominator is 1. And then we've got p squared minus 4. So when you start having binomials or trinomials in your denominator, you need to look for any denominators that can factor and then factor them. So p minus 2 doesn't factor, but p squared minus 4 does. Right here, we can do our difference of squares. Square root of 4 is 2, so we can turn this into factors of p plus 2 times p minus 2. And that's how we're going to think of it for the most part. And as soon as we factor it, should kind of pop out at you that we see that, okay, these two fractions both have p minus 2, so they all need p minus 2. This one has a p plus 2, so they all need a p plus 2. And then the middle fraction doesn't have any denominators. So I'm also going to think of this being as the same thing as what it FOILs out to, which is p squared minus 4. Okay, we'll just make reference to that. Now, we're going to take that LCD again and still multiply it to each fraction. So we've got p plus 2 times p minus 2 being multiplied to each term. Now, it is kind of messy. There's just like really not a super awesome, clean way to show this. But now that I've show it being multiplied to each fraction, I'm going to cancel out the common parts. So my p minus 2's cancel out in the first fraction. I'm left with a p times p plus 2. In the middle, nothing cancels out because we just had 1. So this is plus 2. Now, this right here, I don't necessarily want to write it out as 2 and then p plus 2, p minus 2, because I'd have to FOIL and then distribute the 2 in. So I'm going to remember that it's the same thing as p squared minus 4 when all FOILed out. Okay, so they were the same thing. This just helps me skip the FOILing step. And then my equal sign. In the last fraction, we get to cancel out the whole denominator with that LCD. They're the same. So we're just left with 8. Okay, we got rid of all of our denominators. Our next step is to finish solving this equation. So we need to get rid of our parentheses. We'll distribute. P times p is p squared. P times 2 is 2p. Plus 2 times p squared is 2p squared. 2 times -4 is -8, and it equals 8. All right, this is still quadratic, so we're going to combine like terms and also get this set equal to 0. So p squared and 2p squared make 3p squared. We have plus 2p in the middle, and -8 and -8 make -16. And now it's equal to 0. Okay, to factor this, remember we can't factor if we have a leading coefficient greater than 1. It doesn't divide out as a GCF, so it's our slider. So I'm going to kind of come work over on the side. So now we have p squared plus 2p. 3 times negative 16 is negative 48 equals 0. Okay, now we can factor, looking for two numbers that multiply to negative 48 and subtract to 2 would be, let's see, positive 8 and negative 6. So we write p plus 8, p minus 6 equals 0. If we slide, we must divide. We have to pay that back. We're going to divide by 3. All right. 3 goes bottoms up, but 6 divided by 3 becomes 2. Well, t-bar, if we have 3p plus 8 equals 0, we're going to subtract the 8 and get 3p equals negative 8, divide by 3. So one answer of negative 8/3. P minus 2 equals 0, add 2 to both sides, and p equals 2. Now this solution of p equals 2, if I substitute it in for either p, 2 minus 2 is 0, 2 squared is 4 minus 0, or 4 minus 4 is 0. So this creates that 0 in the denominator, not allowed, so we're going to cross it off. It's extraneous, but negative 8/3 does not create a 0, so it's our only solution on that problem. Okay, number 11. All right, we've got to find our LCD first. So I'm looking here, and it looks like, pretty easy to find this LCD. We've got one denominator of x plus 3, another denominator of 1, and another of x plus 3. So our LCD is that straightforward. It's just x plus 3. So we need to multiply that LCD to, again, each fraction. Okay, cancel out the denominators. So this x plus 3 all cancels out, leaving us with just x plus 6. There's my equal sign. We don't get to cancel anything out, so we need to multiply 2 into x plus 3. And then we've got a minus sign, and then our x plus 3's cancel, but here's a little trick. We're subtracting the whole numerator, so we do need to kind of think of there being parentheses around here because we have to minus both the 5x and the 12. So it gets, again, distributed in. So we've got x plus 6 on the left, and we're going to distribute in our 2, and we get 2x plus 6. Distribute in the negative, and we get minus 5x minus 12. Okay, it looks like this is linear, which is super nice. Makes it a little easier to solve. Let's combine like terms on the right side before we start moving things around. 2 minus 5 is negative 3x's, and 6 minus 12 is negative 6. Okay, let's bring this left side back down, x plus 6. Okay, because again, linear, we're going to move our x's to the left, so I'm going to add 3x to the left, and we get 4x's now. We're going to subtract 6 over to the right, and we get negative 12, and then divide both sides by 4. And we get an answer of negative 3. Now, again, check. If I plug in negative 3 for either of these denominators, we get negative 3 plus 3, which equals 0. We are not allowed to equal 0. It was the only solution, so this is a no solution problem, since our only answer would create that undefined situation in the denominator. Okay, our last one, number 12. We've got, again, not a proportion, but a rational equation. We've got variables in our numerator and denominators. Okay, I'm going to also remember that this 1 has a denominator of 1. So again, once you have binomials and trinomials, they're not matching up, check to see which, if any, denominators can be factored. And we can factor this c squared minus 4c. There is a GCF of c, and then we're left with 1c minus 4 when we pull that or divide that c out to the front. So we can see that both of these denominators have c minus 4, but they need the extra c out front. So it's that c and then c minus 4. You should not put c's and parentheses in the same problem. Okay. So now we're going to multiply c times c minus 4 to all 3 fractions. Our next job is to cancel out the denominator with the part of the LCD it matches. So in this first fraction, I know it's kind of hard to see, but it all cancels out, and we're just left with that 3c minus 2. Okay, equal sign. And then our second fraction, our c minus 4's cancel out. We're left with those 2 c's, okay, but it's really a c times a c to make c squared, not 2c. And then minus, okay, we've got our negative 1. That's going to be multiplied to the c times c minus 4 since nothing canceled out there. Okay, starting off quadratic right now, let's see what happens here. We've got 3c minus 2 that needs to come down. We're equal to c squared, but we need to distribute that negative 1c in. So negative 1c times c is a minus c squared. Negative 1c times negative 4 is positive 4c. So we should kind of notice our like terms are c squared minus c squared, and they cancel out. So even though it started off quadratic, it's now turned linear. So 3c minus 2 equals 4c. So we don't need it set equal to 0. We need to sort our c's and our constants. I'm going to subtract 3c over to the right side for the fastest way to solve. We've got negative 2 equals 1c. We don't even have to divide. And I do a quick check. Putting negative 2 in does not create a 0 in either denominator, so that is our solution.